This is Smarter Cars, a podcast about autonomous vehicles.
This is the finish line. The Stanford racing team has made its way into the history books.
But the most important thing for me is it actually doesn't matter who comes first. It matters that we as a community achieve it.
Early in a technology, a thousand flowers should bloom.
Welcome back to Season 2 of Smarter Cars. This is your host, Michelle Kairouz. In this episode, we talk with Qasar Younis and Matthew Colford of Applied Intuition, which is a company building advanced simulation and infrastructure tools for the autonomous vehicle industry. Qasar is the founder and the CEO of Applied Intuition, and Matt leads their policy work. We discuss the role simulation plays in developing autonomous vehicles, the challenges around validating and testing AV software, and the safety and policy implications. Qasar and Matthew, welcome to the show.
Good to be here.
Great.
Thanks for having us.
Great. At Qasar, for those who don't know, maybe you could start by telling us a little bit about Applied Intuition and the problems you're trying to solve and services you're offering.
Yeah, we are a advanced simulation company. We sell the products and infrastructure that autonomous vehicle companies need in order to develop their algorithms and to get their products to market faster. At a high level, if you have your Silicon Valley hat on, we're an infrastructure company. If you have your automotive hat on, we're a software supplier. And the types of products that we have built and supply to the industry are products that help both, as I mentioned, develop your algorithms, but also ensure safety of your autonomy stack. More specifically, simulation is a pretty large field in itself, and so it can be a bit more specific. We provide multiple types of simulation. So we do both what is generally considered "quote unquote" perception simulation, which is really sensor simulation. We do planning and drive policy and as well. Along with those, I would say, core sim products, there's infrastructure around them. So a continuous integration framework, a framework to use drive data in your simulator, and all the scenario creation and editing capabilities which feed into the simulator. So a fairly robust suite of products. We're a super niche technical company. So for some people that's really exciting. For other people, their eyes kind of glaze over.
Well, we're excited about it. So we'll dive into all of those pieces of it. Just to get started at a high level, it seems like a number of big companies in the space have created their own simulation services in-house. And then there are some other companies now doing what you're doing with simulation as a separate service. I think NVIDIA just announced they're doing it. How does Applied Intuition win in this market against these competitors? What are your kind of differentiating factors?
Yeah, I think as a kind of market sector as a whole, there is precedence here that this is ultimately something that is bought off the shelf. Infrastructure as a whole is something that's ultimately any part of a software stack. And we're not only talking about autonomy. We can use mobile as an example. You can use an internet and desktop as an example as examples. Anytime multiple companies have to kind of do that same undifferentiated heavy lifting, and building a sim product is heavy lifting. So 30 to 50 engineers over multiple years. There's some structural advantages of buying that, because we as a company can go to a company that's consuming and using this infrastructure and say, hey, we can provide you best of breed for a cost that's a lot cheaper than building in-house. And by the way, since we work with lots of different companies at different levels of sophistication, we can kind of see around the corner of the things that you need to do. We never talk about our customers just because of the confidential nature of the business we're in. We supply really to everybody in the industry. But you could have an example where there's a very specific example of where there's a large company working in AV that had done a lot of work in simulation and ultimately had to tear a lot of it down because they didn't know some of the scaling issues that would happen. and so that's one example of why just it's fundamentally so that's one kind of clear example of why outsourcing fundamentally makes sense here. There's other precedents, and automotive simulation is not new at all. It's a very established field. You have large companies. ANSYS is one of them, a $15 billion public simulation company. So there's precedence that this is ultimately not done in-house. If you talk to the most advanced AV providers in the industry who have gone down the path of starting to build their own systems, we have worked with a provider who had built an in-house system, put a lot of resources against it, and then we've migrated onto our infrastructure. They'll all say to you very clearly, we don't want to build this. There's just no good solution out there. And I think we provide, that. And so let's talk about what is a good solution. That's such a broad term. Yeah. This is ultimately a very technical product. And unlike, I was an investor before, one of the adages of venture investing, especially in consumer, is more features do not equal, more usage or better product. Tools is very different. And you need a certain minimum feature set, which already is very high. And then things like we very much focused on are things like what's the most important thing, or what's the biggest hurdle that we need to make sure we overcome? And one of the obvious ones is integration. How long will it take for Applied to integrate our product suite into an AV stack? And we've been, we've architected our software in a way that that is a very, very painless process, and that is a huge advantage. And I think, our buyers are not buying software very willy-nilly. Selling software to software companies is a challenging business, because your buyers are engineers themselves who innately are always going to think, well, I can probably build this. And so you have to have a very compelling product that is easy to integrate, is maintained, is documented, has clean interfaces. It's a really high bar, and we're lucky to have hit that bar, and the company's doing really well because of it. And so at a high level, that's why kind of the in-house versus the external question. Now the secondary question you asked, well, what about NVIDIA? It's difficult to speak about each of these companies specifically. We think highly of NVIDIA, and they're a competent company. But at the heart of NVIDIA, they're not a simulation company. And I spent a bunch of years at Google, and I can tell you, Google just announced that Google Plus was being shut down. And, Google saw Facebook come. And Google's this giant with the best engineers on the planet in the late 2000s, with billions of dollars at disposal and high margin business. And they saw Facebook coming. Facebook comes, gets as big as, and passes Google in social. And so if Google can do, why couldn't they do it is really the question.
Yeah.
Why couldn't Google? And so it's because Google is fundamentally not a social company. And so I don't want to extend that too broadly to NVIDIA or any other player, but fundamentally we're a simulation company. So we have built everything custom in-house, to really create that best of breed product. I mean, we have a very kind of unflinching goal at the company, which is our product and our infrastructure should be so good that the companies that are not using us are falling behind. And that's a pretty serious statement, and it comes with a lot of weight. And I think if for any engineer who's listening to the podcast, you kind of roll your eyes and like, well, that's a real tall order, but I think that's what we're trying to do. That's what we're in business for. So these existing players, and you can go to the other players that are in the industry. There are a lot of great technical companies out there, VRes and DSpace. We already mentioned ANSYS. All of them were fundamentally built for something slightly different than what we are. We are a autonomy simulation company, full stop. And also, the last point I'll say, this is a very long answer. So there's a last I want to say here about the market and dynamics of the markets. We use technologies that didn't exist just a few years ago, and whether that's obvious things like that any I think engineer would immediately recognize, like Kubernetes and WebGL, to kind of more smaller and more custom software innovations that have happened within the subspace of simulation over the last couple of years. And we've baked all of that into the product. And so we literally can do things that other folks can't do. And I think that's really important to highlight. If you're working in a code base which is even 5 years old, that can that can preclude you from building a very compelling product. And make no mistake about it, this business isn't providing infrastructure to AV companies. It's purely about the product. It doesn't matter how well you're known or how big your brand is or how many, how big your market cap is. The engineers who are buying the product have to be compelled through the product and nothing else. And so that's why we're very much focused on being the best in product. Super long answer.
That's okay. We like it. So tell us a little bit about what the product actually looks like. It's looks like a virtual world. How is it different from Grand Theft Auto? Are there a number of driving scenarios programmed in? Take us through it.
So it looks much more like an engineering tool than it does look like something like a Grand Theft Auto or just a virtual world. The analogy I think is a very good one of a Grand Theft Auto or like The Matrix, the movie where you have but really the reason it kind of falls apart is human beings and robots are fundamentally different. We as humans, we can't really isolate our individual senses, our hearing from our eyes, from taste. You can close your eyes and pretend you can't see, but it's not the same thing. Whereas a robot, you have all these distinct parts of the self-driving stack. Let's just say for ease of use, and so that whether that's perception, prediction, planning, controls, you can simulate each individual layer independently. And the reason you want to do this is our company applied is. If it was a cake, the ingredients would be kind of 3/4 Googlers, 1/4 automotive folks. That's also my background as well. I spent a bunch of years at General Motors and at Bosch. I went to GMI for undergrad, and then I worked at Google and Y Combinator and startups, and so very much traditional Silicon Valley. And so, but the point here really being when each of those layers you can simulate independently, and that really, if you're a software engineer, it's really you're creating essentially unit tests or integration tests because you're trying to identify issues that are very specific. If you did the whole world, let's say, and something doesn't work or there's a bug, it's hard to debug. So I think analogously, the virtual world, air quotes, is correct, but practically it's not that. It's much more an engineering tool that's very specific to individual scenarios and individual sensors and the use cases you're trying to figure out. If you're a self-driving truck company, our product is different than if you're a self-driving car company or if you're in construction or if you're in agriculture or another autonomous vertical.
So when you think about there being different things that you're testing, as you're saying, different for trucks or different variables that people want to test. Are you testing also things like weather and daylight or, road conditions and things like that?
Yep. Yeah. And yes. So we do that, and there are ways, there are ways to do that for different sensors again. That's why I think when I say air quotes of perception simulation and why that's slightly a misnomer is because really you're testing individual sensors, and we do fairly robust sensor simulation. So one way to think about simulation as a whole, I think again, if you're an engineer, you understand there are trade-offs for every decision you make. There is no perfect optimized solution. And so when you go into very high fidelity sensor simulation, and the easiest one to kind of think of is a camera, which is very, which is indistinguishable, let's say, to the human eye. Doesn't really exist, but let's for the sake of argument, that consumes a significant amount of computational resources, and so that's expensive, in other words. And so that kind of knobbing of, or a volume knob of fidelity is something that's very important in simulation, regardless of what part of the stack you're playing in. And so a really well-designed product has kind of those knobs to change the fidelity depending on what use case you're working at. You're working at. So at a high level, yes, weather and terrain and all these things, topography is something that's all possible within our simulated environments. But it's a more nuanced actually tool, because you don't want to do fully rendered worlds for every single scenario. It's not a good use of computational resources. And when you're starting to do really large a large amount of simulations, and this is where our continuous integration product really comes in. It can get very expensive, and so we work with our customers to make sure that those how do you optimize your infrastructure so you're not paying crazy bills. Now you mentioned NVIDIA earlier, so just kind of a quick kind of jump off there. NVIDIA has very different goals, right? They almost want you to consume GPUs. And so that's one example of where when you're a hammer, everything's a nail. And for us, we're a simulation, for autonomous vehicle hammer. So we're very specific for AVs. We're not selling GPUs or something else. And again, no disrespect. I know the NVIDIA folks, they're very competent, but that's just an example of why a purpose-built vehicle. For instance, we're a custom simulation engine. We don't use someone else's engine, and that allows us to do a lot of things technically that other folks can't. Now, that's hard to do. To build engines from scratch that for a brand new application is not trivial. It requires roughly like a quarter of our team is PhDs, who really know simulation specifically very, very deeply. And so, that's. I don't know if that directly answered your question, but at a high level, yes, we do. We do road grades and things like that for sure.
Got it.
So it seems like you're saying that really the way we should think about simulation is sort of separately for each piece of the AV stack. Like there might be a failure of perception where it doesn't recognize that's a person walking a bike, or a failure to predict another car is not going to stop, and that those are kind of individual pieces of the stack, and you're testing those basically separately?
Yeah, you can do them together. Again, it's all about computational efficiency. But yes, just in terms of debugging and understanding how what your autonomy stack is doing. So roughly at a high level, when your autonomy stack is connected to our simulator, the autonomy stack doesn't recognize if it's running in the real world or if it's in a simulator, and so that's very powerful because you can really almost you can debug in real time. And the example of the vast majority of our customers, the way that they used our products is side by side with their actual development tools, and so they're making some changes to their autonomy software. And then they're testing it immediately in simulation, seeing what the reactions are, and then back and forth. And so, so you're doing smaller parts of it. Now, there are times where you do want to do more of a kind of an end-to-end test, and that's available. It's just more computationally intensive, and when you're doing simulations at scale, cost really becomes an important consideration. Now, of course, testing on real vehicles is way more expensive and much more dangerous, and can be a real brand hit, and of course a liability, just a legal liability. But there's still a cost that can become very, very prohibitively expensive once you get to scale.
So what does the customer bring to you then in order to use the simulation product? Do they have to have on-road driving experience or data from real-world testing? What do they need to get started using your product?
So definitely the direct answer to that, because I give very long answers, so I've been over my many years of doing things like this. I always get feedback afterwards, like try not to give 10-minute answers. I always get to the really, really nitty gritty. But at a high level, just to answer the question directly, no, you don't need real world data. However, what I would say, there's a kind of big asterisk there, is you're developing any production AV system, and again, we're not talking about the research case. Some folks use our simulator for interesting research work at whether it's a university or a research lab. For production vehicles, you definitely want to actually have physical vehicles, because you ultimately do want to test your AV stack on the roads. I think fairly confidently say you can't only do this in simulation. You still do want physical. Now, there's another reason beyond just testing that you want vehicles driving around, is because it's a great way to capture tons of scenarios and tons of experience, tons of things that your vehicle sees, and we have a set of tools that allow you to get the most out of that drive data. So the answer is no, you don't need to. We allow, and we have customers definitely who don't have vehicles and are just starting off and are just using the synthetic environments and synthetic scenarios. But ultimately, our kind of best practices is you're gonna use both real drive data and a synthetic data.
So what do you do with the real drive data? I'm driving around the roads in Mountain View, and I've got all these drives recorded. Are you identifying edge cases, or what are you doing with the real world driving data?
Yeah, I think that's a part of it. There's a lot of value. Let's just even leave simulation out of the conversation. Why would you drive a vehicle, down El Camino? You're getting data for training sets. You're getting data for just to seeing how your stack is behaving in different environments with different scenarios. All of those benefits you can ultimately put in. You can also get kind of a double benefit of in simulation. So it's identifying edge cases. It's testing your stack. It's both. Simulation and physical driving go hand in hand. I think physical vehicle research, vehicles driving out there and testing go hand in hand. And I think generally our recommendation again for best practices, we work with really across the industry, both Silicon Valley companies and companies that are in Detroit and Pittsburgh and in Europe and in Asia, small and large organizations. Kind of best practices are that. And one of the advantages we have is because we work with so many customers, is we can make sure our customers are kind of approaching simulation in the right way. It's kind of like any other tool. It can be used very effectively with consideration and in the right hands. And for other people, they wouldn't be able to extract that much value out of it if they're not using best practices and are trying to solve very specific problems. I think the point that you're trying to really get towards is what's the workflow and how does the workflow of physical driving relate to simulation? And I think it's back and forth. It's back and forth that you're using both.
And so, is it, you mentioned that simulation kind of has a number of different use cases. Does an AV get better at driving different courses or different routes or facing different scenarios the longer you run it in simulation? Like, is it being used as a training the AI kind of tool, or more just as a test to see where things are?
Training using synthetic data is still a big, I would say, research area. There are some definite values, and we've seen some of it. But generally speaking, I think if you're talking to production AVs, I think they're still more of a question mark than proven methodologies. There are definitely examples I can think of, but just I can't discuss only because of the confidential nature of our customers, that where you can use synthetic data for training. But in terms of testing, simulation is very powerful because you can replay scenarios again and again with updates to your AV stack. And if you've done software development, it's not if you'll introduce regressions, it's when you introduce regressions, what do you do and how do you identify them? And that's, we're as much of a development tool as anything else. So simulation is really powerful for that, which is, let's say, Matthew here has a self-driving car software, and he's made some edits to how it deals with unprotected left turns or some other parts of the AV stack. These are such complicated systems. You just want to make sure, hey, all the scenarios we've kind of gone through in the past, we're still passing, right? We're not failing in certain cases, right? And that's what you want simulation to really do. That's something it's just impossible to do in the real world.
And it's sort of an obvious point, but obviously introducing a software regression into a consumer application does not have the same real world sort of safety consequences as introducing some sort of software regression into an AV stack, right? So that's the other sort of thing that we like to underline is, sort of that consistent testing and sort of consistent development process is obviously much more sort of critical just to the, the performance and also sort of long-term viability of that AV provider.
Yeah, and our value proposition to AV developers really is The simulation itself is quite difficult, and it itself is software that needs to be maintained bug-free. And especially when you start scaling, there's a bunch of work that you have to do to make sure everything kind of stays on the rails. And if one of the things that we like to say is you should work on your algorithms and your AV stack, not on the underlying infrastructure. And so it's kind of like if you're into photography, the general view is like a good camera is one that kind of disappears into the background and allows the photographer to take photos that they see in their mind. And we, roughly are kind of similar. Like our infrastructure should fall into the background, and it just should help you increase your development speed.
I think one of the big questions around using simulation, as you said, you introduce a change and then you're testing the left-hand turns or what have you, is how do you know that is going to translate in the real world, that if it stops for a pedestrian in the simulation, that the car will actually stop for a pedestrian in real life? How does that work?
Yeah, it's a bit of a nuanced answer. You're specifically around validation and verification. I'll just go through the nuanced answer here, and then we can dive into any aspects of it. Initially you want to do careful comparisons on bench tests. In other words, sensors in labs. And then you ultimately move to specific tests in the real world. Let's say your parking lot, and then you ultimately you compare your simulated sensor models against real sensor behavior in the real world. And I'm using sensor example. You can do the same thing for your planning and prediction stack. Overall, what you want to do is you want to validate these submodels first, and then move up to kind of a full system model. And it's kind of and you're working back and forth. You're seeing how does this LiDAR perform, on in the real world in our simulated scenario. What's the differences there? And we really are at Applied are kind of on the cutting edge of some of this work. So I don't want to get too deep into it. But one way to think about this again is you are validating subcomponents and then validating the full system. But validation is a very, very big thing with simulators, period, and specifically also with AV simulation. We have multiple senior engineers on the team who've worked on validating simulations for things in like traditional like diesel engines or fuel injectors for combustion engines, and so these that type of experience is very, very relevant because again, it's connecting the real world to the simulated world and going back and forth. There definitely are ways to do it. ANSYS and some of the, I would say, the traditional simulation providers that are doing computational fluid dynamics have dealt with these problems for long periods of time, for decades, and have pretty compelling products. And it's taking some of those methodologies and bringing them into autonomy, but again, appropriately, because simulating radar in kind of the highest fidelity is incredibly computationally efficient, something that's almost unusable for autonomous vehicle development. So it's validation is very important, as I think your question implies, and there are methodologies to do it, and they all kind of it's like everything we've been talking about. They're all about gradient, so it's stepping up to higher and higher fidelity.
One of the hard things about autonomous vehicles and testing the reliability of the performance is not knowing that if an autonomous vehicle can perform perfectly fine on a given course, let's say 100 times, is it going to perform the same way, the 101st time? If something doesn't work, if it crashes or makes a mistake, it's easier to say, okay, that's bad. But how do you know if something's working well, why it's working well, or if it will be repeated appropriately in the future? How do you think about that?
So scenario, if I read the question correctly, it's really about specific scenarios and the repeatability of scenarios, and I think this is where simulation really shines. Within a specific scenario, roughly what a simulator is kind of the relationship to the dynamic objects in a world on top of a map, for instance, an HD map in this case. And so the scenarios themselves can be structured in very deterministic ways where the agent and actors and the ego, the self-driving vehicle, basically does the same thing again and again and sees if there's any changes in the decisions that AV made, seeing the exact same scenario that it saw before. And then it's all a gradient, so you can move to what we call intelligent actors. Or AI actors. There's different reasons to use those, but it's less useful, and at least from our experience in the pure kind of integration testing use case. There are other reasons why you want intelligent actors or you want a city model. We won't get into that here, but yeah, the point that you're making 100 different times and the 101st time, the way you do that is the scenario is being set up and executed exactly the same way. So when something does break, you can immediately debug it and understand, hey, what did the autonomy stack do differently or think differently in this time that it didn't in the last 100 times? These things can be debugged. It shouldn't be just a black box. I think that's the real implication here is you should be able to understand why your autonomy stack made a certain decision.
Yeah, I think, Rand came out with a study saying, the industry would have to drive, hundreds of millions of miles of testing AVs in order to get to statistical significance on various metrics and to get a level of comfort with performance. Do you agree with that, or does simulation address that problem?
Yeah, I mean, do I agree with that as such a broad statement? So let me be more nuanced here. I agree simulation can play a huge role in AV development. I think there's really it's interesting, when we started the company, there were no articles about AV simulation, and now it's, we're doing a podcast about it. We've just seen this transition in the last couple of years of being in business. So that's heartening, heartening as a person working on the problem that, hey, the industry recognizes this is a real problem and simulation can be a part of the solution. So generally, yes, I agree that you need lots of testing in order to prove vehicle. Now, miles, it's kind of a tricky term. You could have a truck running on a highway with no interesting scenario for millions of miles, and that doesn't necessarily prove anything, or billions of miles. You can just compute at it, and that doesn't necessarily mean anything. So there's something more nuanced there. Is like what is the AV stack actually seeing? What are the scenarios they're seeing?
Yeah, I was just saying, the other way to think about it is it's 100 million miles over what types of, ODDs or sort of, as Qasar was saying, scenarios, right? So is that 100 million, does an ego have to, in simulation, do 100 million miles of the same intersection for there to be 100% confidence? Obviously not, right? But it also doesn't mean 100 million miles over every single, possible sort of environmental conditions that you could conceive of, or road type, et cetera. So it's somewhere, I guess the short answer is it's miles are not an especially useful metric in some sense. It's more thinking about sort of the edge cases and some of the more complex scenarios that these vehicles are going to have to navigate.
Yeah, we generally, again, best practices we've learned is we generally try to steer our customers away from some of these. I don't want to say they're vanity metrics, so there's some value in them, so they're not completely vain, but they're just a lot more nuanced in the discussion now. When there's a scenario where no pun intended, when Waymo says, hey, we're at 5 billion simulated miles, this is a different audience that they're really speaking to at Google I/O or another another conference or report. When you're talking within the industry, and I think most of the listeners here probably are in the industry and slightly more sophisticated, there's just much more of a nuanced approach than, hey, let's get to a X million mile number, and this the stack is safe. That's too broad of a brushstroke.
Right. So between the number of miles and the number of variations of scenarios and edge cases, it's probably finite, but I think it was Rand who said it's effectively infinite. So if you can't ever really test all the different edge cases that an autonomous vehicle may ultimately encounter, like how many is enough? How do you think about getting to some level of, this car has seen and can perform in a reasonable number of scenarios?
Yeah, we think a lot about the scenario test coverage, for the lack of a better word, or a better description, a lot with our customers. So that's one high level point. That's different from within, let's say, a right-hand turn, the permutations and combinatorial mix of behaviors of scenarios that can happen. That's probably slightly more something you can get your arm around, in the sense of, let's say it's a very simple scenario, right-hand turn, pedestrian and crosswalk. You can increment that pedestrian speed at different increments to create a parameter sweep of that pedestrian's behavior. But if you're incrementing by 1/100th of a second, that's less useful than maybe incrementing maybe every 0.1 seconds, or every 1 second, or every 2 seconds. Now if the question to me is, well, what's the right number? There is some statistical modeling there that has generally a correct answer, but you're, as an engineer, you want very hard answers for, hey, this is the increments I want in every single agent behavior, and then anything below that is useless, anything above that is useful. It's hard to answer that in a short sentence. Now, I don't. At a high level, yes, you could have an infinite number of scenarios just at one intersection. I don't agree there's an infinite number of scenarios that are useful. It's still a very high number, but infinite is a very, very big number. So there's nuance there. And if there wasn't, it would be very hard for Waymo to even, look at what they're doing now. And they're about to do a public test in Arizona and Chandler, where they've in some ways have gone through this, through this set of questions.
And certainly it's not unbounded, or if it is sort of this very high number, it's one that a lot of these AV providers are going to arrive at incrementally by sort of, as Waymo is doing, testing in an initial ODD, basically, i.e. Chandler. And then it's not, the set of, possible scenarios is not unbounded there. You're not going to have, for instance, a snowstorm, right? And so you don't have to account for all of those sort of, various permeations that sort of come with those types of scenarios. So it's something, the RAND report, basically, if you were, trying to build an AV or trying to build an AV company, obviously you would look at that and be very intimidated. But the reality is that most AV providers that are doing this sort of wisely and in an intelligent manner are sort of doing it piecemeal, right? They're doing it sort of ODD by ODD. And so when you consider that approach, it's not nearly as sort of overwhelming as saying, like, we have to account for all whatever, 10 million possible permutations that exist in this single city or something.
And then another thing I think, Matthew kind of triggered this thought in my head is really, you hear more and more about this. Well, how far away is autonomy? Really, this is kind of this question that gets talked about almost in every conversation. It's kind of like the adage of how long does a conversation in Silicon Valley have to happen before cryptocurrencies as well. Looks like a half an hour of this conversation. But in the when will AVs come up, and again inevitably in every AV conversation, when we're talking about a completely self-driven car on off-road in a mountain pass, in a blizzard, that's not happening anytime soon. But that's an incorrect way of thinking about autonomy. That's like saying the only way to think about mobile is the iPhone XS. And anything that happened between the Motorola Razr and the iPhone XS was, illegitimate and not really mobile. And that's not true. The first iPhone is quite revolutionary, and the 3S and the 4 and the 5 and the 7 and the 8. And so, the point being is this concept of incremental progress is something that is just hard for the human brain, the way that we think, to really grasp. And if you look back using the mobile analogy, if you look back, do you remember thinking, wow, mobile is here? No, like most people didn't have that epiphany. And there probably is, one example that is probably when the smartphone tipped 50% in 2011, 12 timeframe in the U.S. And you have around that time the advent of many of the powerhouse mobile apps today, like WhatsApp and Snapchat and Uber and Instagram, etc. And so I think autonomy is similar. There were phones before smartphones tipped 50%. And I don't think anybody felt in 2011, 2012, wow, the mobile age is here. But there were many people working on the problem set for many years before then. And then just one day you wake up and you see almost everybody has a smourphone, and it's not something you talk about. And I think autonomy will be similar, except instead of because everyone already has a car, or many people have a car, many people use mobility. You're going to have this very incremental change where the Tesla autopilot becomes much more normal. I think there's something like over 45 vehicles that are coming into production, I think are in now, if I'm not mistaken, or in the next model year, that have that type of capability. GM, Mary Barra, she said very explicitly, every GM vehicle should have Super Cruise, which is GM's version of Tesla Autopilot. Ironically, I think it was even started earlier than Tesla Autopilot, so it's maybe Tesla Autopilot is GM's version of Super Cruise. But the point being is, nobody, you don't see these headlines, which is just like, can you believe it? 2020 Super Cruises in every day. You hear some industry insiders talk about it, but that's the type of incremental approach you'll see, I think, in autonomy as well. And I think that's not unique or strange. Other technical shifts have had similar shapes.
Right. Let's talk a little bit about safety standards and, sort of when cars should be allowed on the road. You raised the point of how it's going to be incremental, in part because the ODD will increase for some of these vehicles as we go. Matthew, do you think that government should require some sort of standardized test, perhaps in simulation, for AVs before they're allowed on public roads?
So our view is that ultimately, yes, there is going to have to be some sort of, third-party external validation process. And there are a lot of parallels sort of, or analogies that you can think of, for this kind of external validation, whether it's financial auditing or, FDA drug trials or what have you. But sort of ultimately the most useful, mental model or analogy for thinking about this is driving as it exists today. I mean, you cannot sort of, under the current, regulatory system, you can't show up to the DMV and say, I drove around Mountain View, I didn't hit very many people, I should be able to get a license, right? And so that's sort of, at the end of the day, you can draw all of these comparisons you want, but I mean, the FAA is another good example of this, right? There are sort of independent validation processes that happen for the airlines, for airline software, a lot of it happening in simulation. And one thing that's sort of important to stress is that, this is not sort of, we view this as win-win in the sense that, at least initially, we think that the technical bar that governments, whether it's state government or federal governments, should set to allow, that a AV provider has to clear before deploying is not one that necessarily has to be super comprehensive, especially if you're doing this on an ODD by ODD sort of basis. But it should be one that at least separates the quote unquote sort of unsophisticated AV providers from ones that have approached it in a really thoughtful way. And so what do I mean by unsophisticated AV providers? I don't mean, startups that are trying to build, a vertical AV from the ground up. A lot of those startups are very sophisticated. I'm talking about ones where you get a few sort of junior engineers that, slap some sensors on a vehicle and want to deploy it. And there are unfortunately sort of a lot of states at this point where you could do that. And that's something that, ultimately, if there's an accident, it's going to set the industry back from a very sort of unsophisticated, quote unquote, unsophisticated AV provider. That's going to set the industry back quite a few years. And so the intention of setting some sort of, technical bar or external validation bar that, that these AV providers have to clear is not to hinder innovation at all. In fact, from our perspective, it's going to accelerate it in the sense that it'll increase consumer confidence. It's going to increase confidence on the part of regulators. And then also, I mean, just from a purely sort of competitive standpoint, a lot of these, AV providers are basically going to be able to say, don't take our word for it that our vehicle is safe. We've passed some sort of standardized test.
So what would a test look like? I mean, I think sometimes testing or having standards is sort of easier said than done. You look at NHTSA and they're having trouble figuring out, I think, even how to write a federal safety standard for autonomous vehicles. And so what would the test look like, and how would you know if an AV passed it?
Yeah, so, this is where, simulation is obviously a very important tool. And, at least initially, as I was saying, I think the way that you would approach this is you have sort of a base, set of scenarios that, again, everyone should be able to pass. And it's worth sort of emphasizing here that the thing that's interesting, I think one of the things that, NHTSA and DOT is sort of struggling with, and we've met with the Department of Transportation several times at this point and think very highly of them. One of the internal sort of paradigm shifts that's happening for them is obviously the FMVSS. A lot of those standards, actually, this was shocking when I used to work in DC in policy, and so I can very much empathize with this. But one of the paradigm shifts that's occurring is basically a lot of those standards that currently exist under the FMVSS. I didn't realize this, but some of them take anywhere between 24 and 36 months to actually develop. When you're talking about testing, 10,000 scenarios, obviously you can't spend, 24 to 36 months sort of developing each of those, right? You just do the math and you're talking about, tens of thousands of years of coming up with some sort of overarching regulatory framework. So, returning to your question, I think the easiest way to do it, obviously, is I think, industry, ultimately we believe that industry can find consensus around what are some of these, you can even call it sort of the 1,000 most basic scenarios that every AV should be able to navigate. Turn right on red with a pedestrian crossing, merge onto a 3-lane highway, something like, some scenarios like that. And then you just start there. And then as you either, change ODDs or want to make the test more comprehensive, you can add in more parameters, you can add in more scenarios. But at the very least, let's start with something sort of basic, right? And we don't think that's an especially difficult sort of technical problem or policy coordination problem. And again, I say this as, somebody who spent years in DC sort of working on policy coordination issues. I think this is something that ultimately a lot of people are going to be able to get behind because it is, it is a sort of safety critical issue.
I would add, I would add on to that one important way to think about policy really is you kind of have guardrails. On one side, you don't want and I think probably maybe the important side, especially if you're a capitalist like many of us are, you don't want the regulatory environment to hinder innovation, especially in a globally in a global marketplace where we are. As the American AV ecosystem is competing against the European and Asian AV systems ecosystems. So you don't want to have such strict regulations. You're actually hindering American companies. On the other end, the other guardrail is you don't want to have such lax rules that if somebody some really unfortunate situation happens where a car careens into a crowd or something like that, and multiple people are injured or even die, then that will get a negative reaction from the general public, and rightfully so. And so I think in some ways the industry was kind of made it through the Uber incident without too many scars, but they can be a real blowback. And so this is something that we as an industry can come together and agree on. And I think it's something that needs to be addressed. It's one of these cases where everyone kind of wants to ignore it and hoping that it'll just work out. But I think it's that assumption is as ludicrous as saying is everyone should just be able to drive. We trust them; they're citizens, and we don't do that. We don't do that, and not only do we not do that, we also have traffic police in order to monitor. And so there is a a middle ground, which allows us to compete on an international platform, an international marketplace, I should say, but at the same time gives some assurances that there's some minimum bar that's hit.
Yeah, you've definitely articulated the regulatory challenge, but in this country, NHTSA has not taken an approach that involves pre-market approval for motor vehicles, right? We have a self-certification regime here, which says, we'll tell you what the standards are, and you companies go ahead and self-certify that you meet them, and then the government has some ways to take things off the market if you really didn't meet the standard. But NHTSA, with respect to autonomous vehicles, has said it's really not going to change this general regulatory framework where they're not testing cars before they're on the road. But it sounds like having this sort of a safety test would require government action before cars are sold, or perhaps even before they're tested on public roads. Is that fair?
Well, I think so at a high level, there are certainly requirements for things like, say, your a lane keep system or anti-lock braking system or your seatbelt or your airbag. You have to hit certain requirements. Now, the point being these are mature products that are generally commodities, so they're a very well-known problem set, and that's why their self-regulation becomes a lot easier. But entire companies, Takata being the most clear example, and recently have gone under when they fail to develop something that's hits consumer standards. And so I think long term that might be the case. I think it's right now we're in a real gray area. Again, the key point being, you can look at the automotive industry as an analogy. In the early 1900s, there were lots of coach makers, and this is when a lot of the modern regulatory and rule frameworks existed. Whether that's stop signs and speed limits. I mean, it's not a coincidence. The signs are all made similar, and we have rules of what type of vehicle is allowed to be on the road in America and not allowed to be on the road in America. So it's not completely wild to think that there are going to be some basic rules. Now, hardware is tested very differently. It's tested on physical tracks because there's a physical component that has to be tested. And now software is different. And the way you test software is using more software. And because it's just the sheer complexity, the complex nature. A seatbelt is very different in terms of testing than an AV stack. So we're entering the analogies are just analogies. You can't take them one for one because they're different systems. And so in this case, where you have software which is very, very complicated, and generally being approached by different companies in different ways. And again, the Matthew point of imagine if you just have a company that, companies like Waymo and Uber have a lot on the line in terms of brands. They're consumer brands and that I think keeps them in check. But imagine if you're not one of those companies and there's a lot of financial upside for you to take real risks. I mean, I'm not the first person to say that there's certainly self-driving car companies out on the roads today that are testing without any sort of approval or self-reporting. Yeah. And so that's scary. That's scary. And I think if you are a company like Waymo or Uber or Cruise, you want some minimum standard. And again, it's not to create an anti-competitive environment, but it's just say, let's have some base standards. So not everyone can just go down to autonomous stuff and buy a vehicle with sensors on it and say, hey, we have a self-driving car.
I think what's interesting too, just to add on to that point, is one of the things that we've seen is it's actually not just regulators and consumers that sort of have more confidence in this sort of external validation system. if you talk to a lot of, and the engineers in the audience will sort of appreciate this, but if you talk to a lot of engineers, they'll tell you that there are obviously risks associated with self-certification, namely sort of overfitting. And you can imagine some of the sort of, not conflict of interest problems, but you certainly have these, it's much harder if you are trying to sort of self-certify and self-regulate to claim that the system has sort of been fully verified to the same extent it would be if it was in the hands of a third party.
Yeah, I mean, simple point would be like, when is the last time you saw a blog post from an AV company that's saying, "Hey, we're just not there yet"? And there are founders, some that are out there that say, "Hey, that we're still working on some fundamental problems," but generally speaking, everything is really great news and really positive. I think the concept that Matthew really highlighted about overfitting, I think is really true. If you have a in-house team testing your own software, there's incentive. There's this human incentive to working in an organization to say, like, let's generate tests based on the way that we look at the world, and therefore the tests are corrupt is too strong a word, but they're influenced.
Right.
Because confirmation bias, I think,
is not even in a, sorry to interrupt. I was say just not even in a nefarious way. I mean, this is just something that happens naturally through the engineering process, right?
Sure. All right. Well, I have a final question for you guys. You've raised a Series A. I assume you're hiring. What kinds of engineers are you looking for?
So you can go to our website, applied.co, or if you can do Applied Intuition. Intuition is just tough to type into a URL bar. Applied.co or appliedintuition.com. We have a careers page, and I think there's something like 10 or 12 job postings there. They're very specific. So at a high level, we are looking for software engineers. That's really our bread and butter. Especially, we have a lot of Google blood, or I should say Alphabet blood inside the company. And, folks who are senior engineers, I think we really gravitate towards, because, it's funny, this is my third startup, and I don't know if it's because I'm working on progressively more difficult things, or because I'm getting older, but, the engineers also that we're looking for are more and more senior, because they're very specialized. But yeah, I think in general, we're looking for software engineers. I think we're now also at a size that there are generalists we are looking for. So if you're listening to this and you're an engineer and you want to work at a company which is growing and making an impact in the autonomy space, we'd love to hear from you.
We have a Detroit office as well. So.
Yeah, exactly. If you're in Detroit, that's also and broadly speaking, Japan, Korea, and Germany as well are places where we are actively building presences in. So if you fall into any of those categories, they're pretty broad, but if you fall into those categories, we'd love to hear from you. And we're in other ways, we're very traditional, Silicon Valley software company in the sense that all the positive things I think that a nimble company has to offer, which is when you write software, customers immediately use it. And working among a competent group of people, I think is probably the most compelling thing. On technically interesting problems is probably the most compelling thing beyond just hey, these are the job descriptions, and do you have the skills that meet these job descriptions?
Great. Well, thanks so much for taking the time to talk with us today. Really appreciate it.
Thank you, Michelle.
Yeah, thank you for having us.
All right, take care. Thanks again to Qasar and Matthew for joining us. We'll put a link to the Applied Intuition website and some other information in our show notes, which you can find on our Medium publication called Smarter Cars. Thanks again for listening. We'll see you next time.